Welcome to the lecture on recursion, guys. It's a topic which many of the people find difficult or confusing, whatever it may be. Today I'm going to explain you how recursion works internally and what's memory linked with recursion. Okay, the memory segment linked with recursion is actually a stack. It's a last in first out based memory, the last in first in based data structure actually. So list is actually a kind of box thing, like the elements gets pushed one over other and gets popped the other way. So this is how a stack works. This works on a principle of LIFO, that is last in first out. Okay, so recursion works on same principle. It uses extra memory. That means it allocates often extra space if we use recursion for a linear solvable problem. Okay, so let me get you an example how linear works. I'm taking example of factorial. Finding factorial is the most common easiest example, right? So this is the program I have written for factorial. That's an easy program. Just go to the program once and I'll explain you over here how the factorial thing works. Okay. According to this program, once the program starts executing, let me take a stack over here. Here we have given n equal to 5, right? Factorial of 5. So with the command, when the execution comes here, it checks if n is equal to 1. No, n is not equal to 1. Then return n times factor of n minus 1. So this is basically recursing a call, like it's calling its function again. That's what is known as recursion, right? Function calling itself again is called as recursion. So it is recursively calling again and again, right? In this, it is taking n times factor of n minus 1. So initially the value of n was 5, right? Okay, let me put a value of 5 over here. Okay, now n times factorial of n minus 1. N minus 1 is 4. Okay, now here n equal to 4. Is 4 equal to 1? No. Then return n times factor of n minus 1. Again, n is 4, n minus 1 is 3. 4. Okay. Now come again. Here n is equal to 3. Is n equal to 1? No. Again 3. Again n equal to 2. Is 2 equal to 1? No. 2 is not equal to 1. Okay. 2. Now 1. Is 1 equal to 1? Yeah, it's very much true. Now it's going to return 1 from here, which will get up into the stack. So literally what it happens is 2 times 1 is equal to 2. Okay, that's what according to factorial program, because I am returning n times factorial of n minus 1. That's why I am multiplying the previous return value to the value which is there in stack. Okay, so 2 times 1 equals to 2. Now this is popped and give its value to the next element which is in the pop, sorry, which is in the stack. Okay, after popping. So this is 2. Now 3 gets multiplied by 2 and gets a value 6. Now again it gives its value to the next element stack. 4 times 6 is 24. Again it gives its value back over here. 5 times 24 is 120. It gives the value as output of the function. So that's basically how a recursive function works. Just basically take a stack memory, just keep on appending things on top of one another. Once you get a base case, remember guys, base case is a must for recursion, otherwise the recursion depth will exceed in Python. In Python basically the default recursive depth is kept to 1000. You can even change that using system inbuilt libraries. If you exit over this, you will get a recursion error. Okay, So to avoid those recursion errors, it's must to have a base case like this. So when you have the base case, the stack growth will stop. Okay, so once a stack's growth stops, it will return the element or the output of that point to the next element in the stack. So basically 1 was over here, 1 returned to 2, 2 times 1 got 2, 2 returned to 3, 3 times 2 got 6, 6 returned to 4, 4 times 6 got 24, 24 returned to 5, 24 times 5 got 120. That's our output. So this is how recursion works. Thank you.